Hello, 10th grade. We're doing our first math lesson together on YouTube. I need you, first thing, to pause this video and go get your math notebook, your calculator, and your pencil. Okay, I know like none of you guys got up to go get those things. Maybe Gabby and Danny, maybe Christy did. That's probably about it. Seriously, pause the video because you're going to need these notes and go get your math notebook, calculator, and a pencil. Okay. So our lesson is 15.1, central angles and inscribed angles. So that's what we're working with right now. I'm going to give you the definition to those and how you can find the measurement of angles. So our essential question right here. Okay. Essential question, how can you determine the measure of central angles? Okay. And inscribed angles, all inside a circle. And I will explain to you what those are. Okay, to start off with, we have three definitions that I need you to know. So the first one is called a chord. So chords, and sorry, my computer just zooms randomly. You got to bear with me. A chord right here is a segment whose endpoints lie on a circle. Okay, so endpoints. So that would be him. This is one chord right here. This is another chord right here. Okay, this would be considered a chord right here. And this one would be considered a chord. They have endpoints that lie on the end of a circle, okay? Okay, then you have central angles. So central angle is an angle with measure less than or equal to 180, whose the vertex lies at the center of a circle. So that would be this guy right here. So this would be a central angle. Okay, this one would not be considered a central angle, okay, because it doesn't lie within it's an angle measure less than whose vertex lie in the center of a circle, and it does not lie, this guy right here does not lie in the center of the circle. He's the center, so that way this right here would be considered a central angle. Okay, an inscribed angle, so when we're talking about an inscribed angle, it's an angle whose vertex lies on a circle and whose sides contain chords of the circle. So this guy right here is considered an inscribed angle, okay? This is the angle right here. This is the inscribed angle, that guy right here, okay? Central angle, inscribed angle, chords. Okay, I just scrolled down the page a little bit. A few things you need to know about understanding arcs. Well, in general, a circle has 360 degrees. So we do know that. You know they have 360 degrees. Okay? So with that, that's one thing you're going to need to know when you're trying to find angle measurements. So we call this the minor arc. It's an arc whose points are on or in the interior of a corresponding central angle. So this right here, we call that the minor arc. Ooh, it likes to zoom. Okay, we call that the minor arc. Okay, major arc is the arc whose points are on or in the exterior of the corresponding angle. So it'd be this guy right here. Okay, he is the major arc. Okay, and then you have a semicircle. Semi just means half, okay? Semi is half of the circle. So that's the line that divides the circle right in half. We call this guy a semicircle. What you're going to need to know coming up here, because there's different formulas for semicircles and then different formulas when you have an arc not in the center of your circle. Okay. Okay, this isn't as important, but if you hear the word adjacent, I just want to remind you guys, adjacent, you know they mean right next to each other. We learned that when we were talking about triangles. Its adjacent partner was the guy right next to him, right? Adjacent and opposite. So what this is saying right here is DE and EF are adjacent arcs, which means they share this guy. They share a line right here. They're right next to each other. They're right next to each other arcs. We call those adjacent arcs. Okay, we're going to skip through some of this because it's more confusing than important. Okay, so this is the theorem you're going to be working with right here. Okay, what that says is ADB. So ADB equals 1/2 of AB. Okay, 1/2 of this. So all that means is if ADB was, I should change my color here. If this, so that means this angle right here we're working with, okay? If ADB was 50, and I know it's not drawn to scale, I know it's not 50, okay? Then this measurement right here, remember when we're working with circles, we always work with degrees. This one right here would be 100 degrees. Okay, let's do another one. So if this one was 30 degrees, this measurement out here, okay, this guy right here would be 60 degrees. And vice versa, right? So if this one was, let's pretend that this one is 70 degrees. So it's vice versa. So if this one's 70, what's half of 70? All right, I know like 5 of you blurted it out. That would be 35, right? Okay, so 35, we know so that is, write that formula down. That is the formula you're going to be using for this. Okay, I want to give you guys a minute, or I guess you can pause to write this problem down for yourself. So write this circle. Okay, draw this circle right here. Okay, and then EDF equals 15. We're trying to find this guy right here. That's who we're working on. Okay, so we know, and I'm going to be changing colors a lot here. We know that EDF is 15. Okay. I'll do red for EDF. Let's find EDF on here. So we have EDF. Okay, we know that its measurement right there is going to be 15 degrees. Okay, this outside guy right here, okay, is going to be 15 degrees. Sorry, let me back up there for a second. So let me, sorry, I'll still go red here. Sorry, EDF. This guy right here is not is not 15 degrees. That would be the inner circle. This guy right here is going to be 30 degrees. So this guy right here, that's who we're talking about right here with EDF, sorry, is 15 degrees. So that's what we know so far. I keep zooming in here. Okay. This guy right here is 15 degrees. Okay. Now I need to determine what is ABE. We're trying to find ABE. Okay. Change his color. ABE. Okay. Okay, in order to find this angle, that's what we're looking for right here, we know, well, a piece of him right here, we know is 44 degrees, right? But he ends up right here. So we don't know from here to here, we don't know what this measurement is. So we have to find what this guy is in order to find out what this little guy is. Because we know half of his angle measure, we just need to find this half too. So FE, we know that FE is 15 degrees, right? If FE is 15 degrees, we also know that BD would be the same angle measurement. Right here would be 15 degrees too, because they share that same chord from here to here to here, from here to here to here. They all share the same chord. Okay, what we're trying to find out though is how much this is from here to here. So in order to do that, we need to figure out what that angle measurement is. Since this one's 15, we know that right here, okay? So we know that this right here would be 30, because it's double, right, of whatever this guy is. So this whole guy right here is 44 plus 30. Which would give me 74. Okay. And so now I know this. Let me change my color again. Now I know this whole side right here, okay? I know that it's 74. I need to find the angle interior right here and he connects right there to right there, right? And my formula says that whatever this has to be half of whatever its outer arc is, right? So 74, so all I have to do to that one is 74 divide by 2. Or if you like fractions, you can always go 74 times by 1/2. It'll give you the same answer. 74 divided by 2 is going to give me 37. I'll put my degrees here. Okay, 37 degrees. So I know that the A, B, E, the measurement, is 37 degrees. Okay. We'll do more of those, but another one I wanted to point out, and this one's a little more obvious. You're going to see these two, and you have to know that, make sure my pin's working here. There it is. The endpoint of a diameter lies on the inscribed angle if and only if the inscribed angle is a right angle. So all it's saying, that's just a fancy word for saying, if these two chords, why is it not drawing? There it goes. These two chords right here, if they are, oh my goodness, it's not letting me draw here. Okay, so if this chord right here and chord right here, if they cut the circle in half, make it a perfect semicircle. I know that line's not very good, but it's a perfect semicircle. That means it's right in half. No matter where it is, it's always going to form a right angle. Okay, so whether it was from here to here, it'll always form a right angle. That's all that's saying. So if this is a right angle, you know that it is 90 degrees. Double of 90 degrees, this whole outside arc is going to be 180 degrees. So that's just good to know when you're working through problems if you have one that cuts right in half and makes a semicircle. Okay, so here's another circle that we are working with. If you have the circle, it says 84 degrees, so that is, this right here is 84 degrees. Okay, so once again, we know that this is 84 degrees. We know that this guy in here has to be half of whatever 84 degrees is. So DGE, we're looking at, DGE is 1/2 of 84. So if you wanted to solve that, you could do it the two different ways. If you like fractions, you can go 84, okay, times it by 1/2, or most of you just like to divide that by 2, okay? So 80, oh, sorry, 80, where did I get 82 from? It came out of nowhere. 84, sorry, divided by 2 gives us 42. So DGE is going to be 42 degrees. Okay, now we have EFD. So EFD. Okay, so even though we did different points in here, we have G in the middle right here. So we have G in the middle right there. On here, F was the middle right here. However, they still have the same 2 points for their arc. So F still went to E and to D, and G still went to E and to D. So therefore, their measurements are actually going to be the exact same. They both had 84 as their endpoint. So if you wanted to do the math on that, you totally can. You can still say, well, I mean, if you want to say E, F, D, okay, right here, you're looking for this guy right here. Its outer angle is 84, so it'd be the same thing. 84, okay, divided by 2 would still give you 42 degrees. Okay, so that's kind of a little simple way you can look at it. If you know if they share the same points, even though they're different middle points, they're still going to be the same measurement. So DFE has the exact same measurement as DGE. Kind of cool. Okay, make sure to get onto Seesaw and do your work on there. Remember that it's going to be due Sunday at midnight. Okay, so if you have any questions, feel free to reach out to me and get a hold of me or text me, and I can and meet up with you. And then on Friday, we have our open hours. So if you want to have like a Zoom call for questions, I can help you there and write it out for you. Yep, so you have plenty of ways that you can reach out and get more information. All right, guys, have a great day.